So the first operation we learn is addition, and that's how we first start teaching our students as well. We combine things together. After we learn addition, then we can learn subtraction. And subtraction really is the inverse of addition. It is the opposite of what's going on with addition. And so we can think about it in terms of addition as well, and we'll see that in just a second. We've got quite a few different models here that we could use. Some of them will have pictures with them, some of them will have words and pictures, and all of them are valid. I know I've said it before and I'll say it again. Each one of these is important. We can't just stick to one because sometimes one doesn't fit a given situation, and also our students aren't all the same. They might think differently, so we need to have different tools available for each student and their learning style. So first here we've got probably one of the most common, our takeaway model. Again, remember with all of these, our goal is to teach the students what that subtraction symbol means. They don't know what that little dash means. It is our job to teach them that that means to take away. So like visually, I could start with 5 of these, and I want to get rid of 3 of them, so I'm left with 2. Also could think about this one in terms of a word problem. I could say that I had $5, but I spent $3 at the store. How many dollars do I have left? So we can think about using the subtraction whenever we're getting rid of something. I do want to put up here something that we don't want to see. So I'll put it up here in red because I don't want to see it, and then I'm also going to erase it. If you just show me that for takeaway, I'm not really sure what happened because as a student, I don't really know what that line means. For the takeaway model, visually, to show a takeaway model, you have to cross things out. You have to cross out those X's. If you really wanted to show that subtraction, you could go through and kind of pair some of these guys up, and we can see we're left with 2. But we've got, in takeaway model visually, you've got to actually get rid of, cross out some of your items. I just used X's here. You could have little fish or flowers, hearts, whatever you wanted, but you have to get rid of them. Now, I mentioned a second ago that subtraction is the inverse of addition. And we saw that with our fact families, that we could rewrite subtraction or addition problems and turn them into subtraction. And we could do the same thing with a subtraction problem. This is called the missing add-in. These 2 numbers are called add-ins. So there's one missing. We don't know what it is. I can think about this as 3 plus blank equals 5. And maybe I really know my addition facts, and I would say, oh wait, I know that's 3 plus 2, so 2 has to go in the blank. So really just reframing this as an addition problem with a missing piece, kind of like a puzzle that we have to solve. And this is our very beginning of algebraic thinking. Whenever we have something that's missing and we need to figure out what it is. So technically when I do a missing add-in, I am already teaching algebra, even though there's not anything like an x or mx plus b or any of that stuff. This is algebraic thinking because I'm finding something that is missing, an unknown variable. Next, we've got the good old number line. The number line, we do want to make sure that we put plenty of numbers so that we can follow what's going on. We want them pretty evenly spaced out. They don't have to be perfect. We're going to start at 5. And when we think about subtraction, we're going to be going to the left 3 jumps. And so we get 2. Remember that putting the arrow there is really important so I know which way you went. Show me where you started and where you went. I drew a little person. You don't have to draw a person. You can draw some sort of little starting mark or something like that. But you've got to show me a start and kind of an end there. So the easiest way to do that is something at the beginning and an arrow to show that end. Now the one that gets people is comparison. It's gone over all the time. We don't remember it though. We think subtraction is used just for that taking away effect. But we also can use it to compare. So this is a valid form of subtraction, but a lot of times students don't think about it using subtraction. They think about subtractions only when we're getting rid of something, which is kind of what the models up above show. So this is another use of subtraction. So let's say that Maria has 5 stickers. And we can say Nick has 3 stickers to keep with our same number. How many more stickers does Maria have? That's our comparison. So that's that same problem, 5 minus 3, but written kind of asked in a different format. This is a subtraction problem. One thing that gets people is that more. A lot of times people think more, we're adding, but we're really seeing the difference between these. The difference between Maria and Nick. One of them has more than the other, one has less than the other. So we are comparing them. But again, if you think about it, what's the difference between Maria and Nick? We can kind of hear that subtraction a little bit more. All right, so to finish up this page, take a quick pause and see if you can rewrite that subtraction sentence into an addition sentence. So go ahead and hit pause and give that a shot. All right, let's see how you did. The x and the 5 are our add-ins. So we would have x plus 5 equals 8. Or you could have 5 plus x equals 8. Remember, the order for addition doesn't matter, so both of those are valid answers.